Good morning. I'm Adam Rothschild from Voxel, and I'm joined here by Nathan Patrick from Sonic.net and Alex Pilosov from Pilosov. And we are presenting on passive Metro WDM, aka capacity on the cheap. How it works? Well, put simply, we have single mode fiber with multiple wavelengths, also split into what some might call colors or lambdas coexisting separately. We use pluggable optics as an enabler, and we use low-cost passive optical equipment, particularly gray market, to multiplex it. One that we are not talking about is proper active WDM systems. There are a number of vendors out there. You can give them a lot of money, Cisco, Ciena, Movaz, whatever. Give them a lot of money, they'll give you a proper solution. That's beyond the scope of our discussion because we're trying to keep things as lean and profitable as possible. As for why WDM in the Metro, well, put simply, the cost of dark fiber IRUs is quite reasonable, often comparable to the NRC and MRC costs for a gigabit wave or other lit service between carrier hotels in a given city. This solution is low in CapEx and OpEx. It's a good tool for fiscally responsible regional networks looking to upgrade backbone capacity. And with that said, I'm going to turn the microphone over to Alex, who will be talking more about the implementation.
What exactly is WDM? You can think of it as basically a prism. You have mixed light coming in, and it separates by wavelengths, by the color, and gives you multiple different channels that you can use for different signals. You can do it with multiple options. We are talking about just doing passive systems where the optics is pluggable, and there is all the equipment is basically passive. These are some pictures of the equipment that we have. These are pictures of components on top for the passive filters. And on the bottom you have assembled panels which have a single fiber coming in, dark fiber, and splits into different wavelengths that go into different GBICs for actual equipment. So what options do you have for WDM? The first one is what people usually start with. It doubles your capacity on existing dark fiber. If you already have dark fiber and you are using it for a single circuit, you can very easily and at a very low cost double the capacity. Proper term for this is wide wavelength division multiplexing. This is usually also referred as GWDM, and G stands for gather. The wavelengths used in this are 1310 and 1550, which are basically the LX and ZX wavelengths. So the transceivers are easily available, the transceivers are very cheap, the splitters are cheap. You double your capacity at a very low cost, and you can use this for 10 gig just as well. The next option is CWDM, which is coarse. Each of the CWDM channels is 20 nanometers wide. You have 8 channels normally used. So you can have 8 gigabit channels per single pair of fiber. The cost for the passive equipment is about $1,000 per strand per end. Cost for each GBIC is about $1,000, between $300 and $1,000, depending on the vendor that you are buying it from. A couple of problems with that. There are no Zen packs, so you are limited to 8 gigabits with this system. The next option is dense wave division multiplexing. Dense means each of the channels is far narrower than coarse channel. For example, if coarse channel was 20 nanometers, dense channel is 0.8 nanometers. So you have roughly 24 dense channels per single coarse channel. The capacity, obviously, with DWDM is far higher. The standard systems are about 160 channels. You can do 10 gigabits on each of the channels. So total 1.6 terabits of capacity on a single pair. And this can be expanded 4 to 8 times with some of the newer equipment. The problem with DWDM is that general equipment is, particularly the active equipment, the active optics, are very expensive because of the higher tolerance requirement. The 0.8 nanometers require thermal stabilization for the laser to keep the wavelengths. The benefit of the wavelength division multiplexing is you can easily scale. You can start with two-channel system, then put in additional filters and extract additional 8 channels, and then put in the WDM system to extract additional 160 channels. And the scalability is more or less linear. The tools that we use to test the system and to implement the system, basically the most important tool is optical power meter. You measure the output on each of the channels, and that's how you troubleshoot the system. The next most important tool is spectrum analyzer. You plug it into the dark fiber and you see what frequencies are currently in use on dark fiber and what is the power level of each of those frequencies. Some of the problems that we experienced during the implementation of the system, commercial systems for passive multiplexing are not readily available, and if they are order of magnitude more expensive than the systems that we build ourselves. They require the knowledge to put in a WDM system is generally not available, it's not considered to be network engineering knowledge, so it's an intersection of fields of fiber and network engineering in order to put a complete system. The vendors for SFP and GBIX optics, we see that there is a lot of problems with quality control, so we've had problems simply because the vendors don't have the working active optics. The equipment for testing is also not free, and it's a significant part of the cost is your testing equipment that you need to have. And obviously the important thing is that what happens if the engineers that develop the system and tested the system gets hit by a bus, who is going to be able to maintain the system? There are some exotic options that I'm not going to talk about. It's maybe a future nano talk. The bottom line. So you can have a 2 gigabit system over dark fiber for about $1,000. You can have 8 gigabit system for between $5,000 and $10,000, and similarly for a 20 gigabit system if you're doing 10 gig. The 10 gig will scale very linearly to multiple 10 gig channels, and each of those is about 10 times less than commercial Sienna or Movaz system. These are the vendors that we have used in our network. So if you are looking to re-implement what we did, we suggest that you use that. So, any questions?
Martin says, what do you do for timing? You didn't mention like bits clock or any kind of timing, and I'm not sure. I know you need it. I just didn't see it up there.
Timing?
Yeah, network timing. Don't you have to time?
No, there is no need for timing because each of the channels is completely separate, and this is just a GBIC, so there is no specific timing needed to run this.
Mike Hughes from Lynx. We have some experience of networking this way. One of the things to particularly look at if you're trying to do anything like WDM or go bidirectional on strand of fiber is to look out for back reflections. We had a system that was based on running several channels bidirectional over single fiber, and what would happen is the transceiver at one end would see itself reflected back to itself and declare link up. You've got to be very careful with isolation in your components to stop back reflections.
Well, we've had this problem. The answer is don't run two wavelengths both bidirectional. So don't do that. Yeah. You can do that using circulators, but that is kind of, again, it is possible, and I would love to talk about it, but we are out of time.